Yeah, when I was asked to give a keynote, I was really thinking what I should talk about. When you hear IBM talking about big data, for sure that's our key business. Over the last decades of years, we are trying to handle that. But I want to give you a short excursus about IBM in energy and utilities, but touching the big data topic as good as I can from a perspective, I would say, eagle view, 10,000 feet, and we can dig into details if you want to. I'm with IBM since 15 years now. I'm originally a field engineer, and when I entered IBM, I was a little bit curious if I'm right in that company, understanding how energy flows, but no clue about data. So finally, I was also educated that data is a big portion of a utilities business. So I try to give you something of that experience back today. And in IBM, we started roughly 12 years ago to focus on industries, and energy and utilities was one of the key industries of focus, of interest. And as already said, we went through a major transition in the 90s. When client-server technology was invented, IBM was struggling with the mainframes and the centralized systems. So if we compare that a little bit to the utilities, centralized systems to decentralized systems, there is something like analogies which might have an impact. But it is something which gives a sense of experience, which could be leveraged from, but the industry is definitely not comparable. Nevertheless, big data, we are at Lake Constance, so we have a mass of information. The information produced over 24 hours is something which has 18 digits of zeros, and then the number comes. So in English, it is quintillion. That's a number. I just put it up there that you can see how long this number would be. And this is the amount of information produced each day. It's unbelievable, and I could not even handle what does this mean. But we tried to compare it a little bit. So this means that each inhabitant from 0 age to 99 years old has to read 340 newspapers a day. That's the amount of information produced each day. And that's incredible because a lot of this information is unstructured, available on social media, weather forecasts, weather information, customer information, asset information. And utility industry is one of the key industries which has over 80% of unstructured data to handle. And we are not talking about quintillions of information a utility needs to handle, but we are talking about petabytes which need to be worked with. Petabytes of information, that's still enough. It is not a simple thing to handle that kind of information. But historically, we went through somehow a journey. Each time when we reach a border, we overcome that border and we create something which extends our way of living, our way to handle things. Physical limitations. Early, when you see the pictures here on the wall, everybody was walking from one point to the other. Then you had the horses and you have to travel a little bit differently. Then ships were invented. You can travel around the globe. Airplanes make it even faster. And nowadays we are talking about digitalizing information going around the globe very fast. 3D printing is invented, which gives us a complete new opportunity. And also on the connectivity side, if we talk about information exchange today, we started all with something like signals. Signals like lamp or fire and also acoustic signals. And nowadays we are exchanging information when we stand up in the morning with Facebook, Twitter, and any other social media, whatever. And on productivity, I do not need to go into details there, but it is obvious that the amount of information we are working with is giving us always the opportunity to take a next step, and take a next step, and a next step. And in that regard, let me come down to, or come back to the utilities business. Some of you may recognize this picture. It is not a new one, but it's still reflecting quite well what we are talking about. So the systems in a utility are mainly traditional, centralized, organized. If we go further down the road, and we have spoken a lot this morning about the new scenarios, I heard the word microgrid, I heard something like advanced distribution management, renewables injection, renewable systems, solar, wind, e-mobility. All of that has its right and is playing an important role in the future of the utilities business. But even if we talk about the future, we need to handle this kind of information gathered from these decentralized generation spots. And back when I did my study, we and the professor said, well, an impact on the low voltage grid side does not harm anybody on the TSO side. We overcame that in the past 10 years quite heavily, and sometimes it hurts, sometimes not. But in fact, an impact on the low voltage grid side can really have some influence to TSO, at least to the mid voltage grid. And therefore, we need to have an idea how to get information and how to work with that kind of information. What we see is that we are reaching a point where we have two different levels. We have the bottom-up level, where we have a lot of data, unstructured, available, and needs to be organized and structured. And we have the traditional information from our SCADA systems and from our working systems we have implemented over the last 25 years. And in the middle, you need to have a layer which makes both sides connected, and that you can understand which kind of information is coming from which direction. And I had a lot of discussion the past 10 years. If SCADA will dominate that market? For sure not. SCADA was not built for millions of meters or millions of endpoints. So it will be something in between. So data collection and working with the data needs to be organized differently than a traditional utility grid was built a couple years back. What's the future of a utility? And we talked about 2030 and 2050 this morning. I will not go that far. The next 10 years will have some impact. And as I'm currently in IBM on a global responsibility, this may reflect more the global level, maybe not Baden-Württemberg and even not Germany in time of speed at the market. But if we listen, the last panel, Finland and also Italy and other states in Europe, they have already done some of these steps which are mentioned here. And we see that data will dominate all of these steps in a different way, but they will be dominated with the amount of data which is available. And new customer does not mean that the customer is going to be new and changing, but the customer has some behaviors which are not common as they were in the past. And smart appliances could be a fridge, could also be television, could be a management system. And smart home is something which is more or less a buzzword, but it is happening and it is available. It is not new and it is not to be invented, it's already there. Loads move in space, and DSO and distribution resources available. There's an app for that. Some of us are young enough to work with smartphones. I'm in between. I work with a smartphone, but I was not used to in the beginning, so it's a sense. But in the future, there's no doubt that for everything you will have the capability to use an app. Automated demand response, for sure. As we go more and more towards demand takes place, it needs to be somehow automated. And affordable customer generation. This is something which needs not to be explained in Germany, but in some other areas in the world, that's a huge topic where the rooftop panels are not that heavily installed as we have. On the grid side, also the grid will not be completely new, but it will be transformed from traditional way of serving from a centralized power plant to more smart technology. Microgrids will happen more, and it will be more, maybe another buzzword is it will be more on a VPP, on a virtual power plant kind of level, which generates opportunities for microgrid and handling a local demand response capability. Energy storage. So if we follow Tesla, everybody can get his battery in the cellar, and then we have maybe the capability to work with that information as well. I expect that the utility will handle that in the near future. It is not easy because also a lot of data which needs to be kept and handled. New Deal, I don't think it is a new deal, but regulatory framework will give us a lot of brain work to address these challenges, and that consumers are more active and agents will enable them to participate in the market, that's for sure. So we talked about the new role of a DSO this morning. We named the new role the energy integrator. The energy integrator is the one who has the power to use the data collected from different sources, from different consumers, from different parts of the grid, and work with pattern and work with processes and automation capabilities, analyzing the data in a very short time frame, and work with the information to optimize grid and stability. The digital customer, for sure, the more data we can collect from social networks, a customer will get a better, tariff. I'm not a retail expert, and I may have not a sense how a retailer can act, but I was told that the retailer has the opportunity to generate tariffs along demand of different groups of clients. That's for sure. It's the same as we have seen when mobile telephony was invented. There were new tariffs. Nowadays, everybody is talking about flat. And if I talk about flat, don't we have flat yet on utility bills? So it is just a matter to come back to the same idea after a couple of years. And disruptive innovation, we in Germany have seen a lot of this innovative, small, decentralized generation happening already. We have firms who are really proud and good in establish the technology, and the question will be how we can interact with this information and how we can make sure that we can handle the decentralized generation by gathering information from data as well as the traditional way of serving clients. So, as I said, the energy integrator is capitalizing grid injection and the data from the low voltage side. The customer experience covers a lot of information around clients in each of the different areas and the different sense of data, transaction, demographic, interaction, behavioral. So you see that a lot of sources will need to be combined. Analytics driven, and analytics brings us back to the discussion about big data. Big data starts not with something which happens suddenly. You need to go through a wave, you need to go through a ramp, whatever you name it, where you have experience to monitor to gather information for monitoring purposes. You automate your network. That's the first step, and that's a step which we have reached in grid area quite a long time. But the more we go to the low voltage side, the more we are lacking this kind of information. So monitoring metering infrastructures was a topic this morning, is for sure one of the next steps which are necessary and important. On the one hand side to have a clue what's happening on this last mile, and as well as working with the data collected from the meters. Second step, connect the participants, means that a prosumer, which is a production side and a consumption side in one instance, needs to be connected. So you need to have the possibility to work with your produced energy. You have the possibility to participate in the market. We were talking about marketplaces this morning. That's not a simple thing. Data is for sure needed to make this happen. I haven't seen a lot of real marketplaces yet in the world. And from an economic perspective, that's for sure a challenge for the near future. We are all faced with, and we need to have a sense what this means when I can trade my own solar production, or if I can share it with my neighborhood, or if I have the possibility to work in different instances. Sense and response, this is what a SCADA system is doing over a long time. But sense and response is also something which goes down to the distribution level and even down to a charging port, to a heat pump. In the US, to air condition. In Germany, to smart heating systems or overnight heating system, electric heating, things like that. So it is to have an understanding when something's needed, and we have a lot of these devices connected with radio frequency signals, and I expect and I guess that we will change from a radio frequency kind of steering and steaming to a more sensitive demand response capability, leveraging the data collected through a metering infrastructure. And the last step is, if you have data collected, analyze the data and work with the analysis and the algorithms to optimize infrastructures. Prevent outages, prevent problems which makes a grid unstable, and work with that kind of information in a way that you really have a flexible and dynamic way of answering incidents happening in low voltage grid, mid voltage grid, as well as high voltage. So this is just to give you a sense when we are talking about big data. This is a huge amount of data which needs to be structured in a way that you are able to deliver results. I have some of examples, or I have sampled some examples from projects around the world. We see the growth of data, which will have a huge impact to utility. We are everywhere in the same way, trying to reduce costs of delivering and cost of asset management. So it is something, if I have the data available, and I give you an example what this means. Installing a smart meter technology for meter to cash purposes only will never reach a business case which is fair and stable. Leveraging the data for managing grid outages, or like the Italians did in 2003, managing the theft of energy, this will get you a business case and return on invest. And you see the numbers, and this is just another mean why we are talking about big data. And big data is helping us to reduce, on the one hand side, costs and to maintain big infrastructures in a way that it is manageable and also reliable for the near future. I want to give you some other examples where big data is either already invented or helping the utility industry to overcome issues. And issues does not mean that everybody has a problem, but there are different scenarios which cause pressure, which need to be maintained in a way that you can act properly. And the one example I always have, and some in the room will hate it, but if I have an outage, currently the sensor is the customer calls the call center and says, I'm out of energy. And the first answer you get is your neighbor also out of energy, or is the street light on? So it's afternoon, 3 o'clock, I'm alone at home, I don't care about my neighbor, and the street lights normally are not on at that time. So what is the feeling and the sense I get from this phone call? The utility has no clue. At that moment, I'm not aware that I talked to a retail call center agent who might sit somewhere, but not in the utility. So the DSO may have another answer for me, but I call the retailer because I have a contract with the retailer. Nobody knows it. But there is an opportunity to get this information in a way together that this call center agent can provide you with some information. And this is a possibility to say, well, we know that there is an outage because our AMI infrastructure have told us. We know that this incident will be repaired or restored within the next 15 minutes. If I get that kind of answer from a call center agent, I feel confident. And I said, well, okay, they know exactly what they do. That's not happening in Germany. It's not happening somewhere in the world, but there's something like a wishful thinking. And we see a lot of utilities working towards exactly that outage information, outage prevention on the one hand side, but also get the information together. I was in Africa the last 2 months. In Africa, we have the first client using Facebook information for outages. So they read Facebook entries which are occurring in the area where they serve their clients. And the clients are faster in typing that they're out of energy than they took a phone call. So the utility is using that kind of information currently to have a sense what's happening and inform their internal call centers about situations which they recognize over social media. Just one example. Yeah? If we go towards risk and compliance, just another corner of data, a lot of regulatory requirements around the globe afford that you need to report either outages, lengths of outages, what the SAIDI and SAIFI times are, and to make that happen in a way that it is automated, because sometimes it occurs that you have outages happening more frequently, sometimes not. You need to have a clear documentation when it happens and how it happens. Also, a lot of data which you collect from systems, and you need to make it compliant to regulatory requirements. Earlier, we did it with Excel sheets, and we did it by hand. Nowadays, you cannot do it by hand anymore because you have too many connection points which report automatically about outage times and things like that. Network planning and distribution operations. If you have a sense about loads in the grid, you have also a sense about stress factors for your equipment. You know exactly how often a transformer is on limit or even over limit. At that point of time, you can decide if the 40 years lifetime is something which you expect the transformer to fail afterwards, or if the transformer was never stressed before, then even 5 or 10 years longer lifetime is applicable, and you can use that without investment. In Germany, we quite often intend to do it on a timely-based manner. We see more and more utilities going the other way. And we had one European client who had finally a low voltage grid monitoring system invented, and they reduced the investment for the second year by 85%. And this does not mean that they can extend it for the next 5 years, but the next year was a year with huge investments planned for mid-voltage transformers. After they recognized that they were never stressed, they kept them for another 10 years. And not investing was the key success factor for that project. And we were talking about this country this morning quite often. It was Denmark. And it was something which was a surprise in one regard, but even if you analyze the data, it was not really a surprise, because you really can follow a line where you can see which transformer has stress and which not, and this makes it much more simple. And even if you go back to ABB and Siemens, they will tell you the same. If a transformer is not stressed, the data sheet says you can extend your lifetime for a couple of years, and that is finally preventing new investments. So I can talk about that for another 3 hours, but I was told to keep everything in 30 minutes, which I have reached now. There are a lot of other examples on the slide. It is just to give you a flavor in which way different areas of utilities are benefiting from information they gather. As I'm currently responsible for metering, a lot of these ideas are coming out of AMI, Advanced Meter Infrastructure projects. But this does not mean that the low voltage grid side, the mid voltage grid side has not the same kind of efforts. And all the situations you see here are either projects driven by European Union or worldwide funds, or client needs and client projects we are in right now. Thank you very much.